Okay, so let's get started, guys. Today we are going to talk about all the data types. Right, we'll look into them. Practically, we'll do, and then we'll understand what are these data types used for, and we'll talk about the ranges and all those things put together. Okay, so let me share my screen. I'll share my screen, and then we'll go ahead with that. So we are supposed to start from your use of all the data types. Okay, so we'll try to see all these things. Now we'll start with the Boolean now. First, the Boolean data type. Okay, so Boolean where flag equal to true. So as you know, Boolean is basically a type which can store the value either true or false. Is not it? So you can say where flag equal to true. That means a flag variable is defined a value called true. Okay, or you can say where flag of Boolean type is equal to false, right? So here if you see, this is a concept of what type inference, right? Wherein what happens is you don't have to define the type of the data, right? So based on what is here on this side, the based on whatever is present on this side, this type would be decided, right? So that concept is basically called as a type inference, and that's what you can see here, right? So number one is like you're just defining a variable called flag and assigning a value called true to it. Done. Number two, you are saying where flag is colon boolean is equal to false, right? And when you do that, then what happens? You are explicitly telling that, okay, I want to define a variable called flag, and that should be of boolean type, and it will have a default value equal to false. Okay. Now, in all these things, in all these two examples, if you see, I've just used where, but you can also use where. Okay, no good reason why did not we use where. Okay, you can use either where or you can use where. Okay, now Scala where flag colon boolean is equal to 12, this is wrong, right? So you cannot say variable flag of boolean type is equal to 12. 12 is an integer, and you cannot say I want to pass this integer to a flag which is a boolean type. So this is not correct, right? So let me go back here and I'll just say Scala. We'll try to do them. Okay, and then we'll get started. Right, so we got into the Scala prompt here. So I'll say variable flag is equal to true, right? So we'll get a boolean of true type, boolean type value, and its value is true. And then, or you can say variable flag of boolean type is equal to false or true, whatever, right? Now what you cannot do is you cannot just say is equal to 12. This is not correct, right? It is saying found is integer and required is boolean, right? So that's what it is. So let me even change it to well, because it's the best idea to use well always, but as I said, it will work for where as well. Now let's look into this. Well is true is not true, right? So what I'm doing is I'm saying well is true is equal to not true. And what is the value of not true? Not true means false. So this will be false. Okay. Again, well is true is equal to not true. So look into this. What we have done is we have tried doing the same thing with a space and without space, and it did not work. Let us see what happens this time. Okay. So I'll just say paste well is true is equal to not true. It said false, and let me try it this way, right? So let me try it this way. I'll say well is true, okay, is equal to not true. So when I do this, then it really does not work, if you see, and it is just because of this space, right? So think about it, how much critical the space is holding here, right? Because it's saying it's trying to evaluate this is equal to not true. Let's try something like this. Can I not write it like this? This worked. Why? Because of this braces, right? So the braces is helping you. You're saying I want the braces to be evaluated first and then give me the output of this. So be very cautious when you are using it like this. Okay, so I'll also put that braces stuff. So this should work, right? So I'll say no space but braces. Now well is flag is equal to not true, right? Well is flag is equal to not true. So not true means what? False. So it should give you false. Again, well unequal is equal to 5 is not equal to 6. So this can be an expression, right? So see, it can be an expression which can either give you true or it gives you false. So you can say, well, unequal equal to 5, not equal to 6. 5 is not equal to 6 is correct. So it's true. Okay. Again, well is less is equal to 5 less than 6. Yes, 5 is less than 6, true. So it is true. Okay. Again, well equal, sorry, unequal and less. So what we did is this was unequal and this is less. So this is true and this is true. True and true, it becomes true. Okay. Again, well, definitely false is equal to false and unequal. What is unequal? Unequal is true. And what is this? False. False and anything is always equal to false. Okay, because and operation means both has to be true. So this will give you false. So let's do this all right. So we have done till here, right? And then this is okay. I'll just skip that, but then let me do this. It's all simple and easy, right? So just say paste well unequal equal to 5 is not equal to 6, true. Yes. And then it would also give you true because it's a boolean. Okay. And then this should give you true because this is true and this is true. And if one of the condition is false, then it should give you false, right? So that's how it works. Okay. Now let's talk about the next topic. So now we'll talk about and or. This is double. Okay, so 2 times you write and 2 times you write this pipe, and this becomes and or. These operators, right? These operators are called as short circuit operators. So these two operators are called as a short circuit operator, which means the condition is very simple. It says if the first condition is sufficient to declare the final result, then second condition is not evaluated. That's what we call a short circuit operator. Okay, so why are these two called a short circuit operator? Because when you are using them, and if in the expression you see that the first condition is sufficient to derive the result, then the second condition will never be executed. What do you mean by that? So say you have a condition like this, condition 1, and you write and you'll say condition 2. Okay. Now see here, if I look into this particular if I look into this particular expression, I may say, well, result is equal to, right? I may say, well, result is equal to condition 1 and condition 2. So technically, if you see, you will feel, okay, now I have to evaluate this condition as well as I have to evaluate this condition so that I can get the result, right? But then what is this? This is AND. Okay, this is AND. And in AND condition, when can this result be true, guys? Here, if let's say condition 1 is true, let's say if the condition 1 is true, then do you need to evaluate this condition 2 as well to get the final result? Yes, right? Because see, unless until you don't know what is this, right, you cannot really say the final output would be true. What if you get their false, right? It has to be true. Then only you get the final output, right? So if the condition 1 is true, then evaluate second operation, right? Now, if the second operation is true, then only the condition would be true, right? If the second condition is false, then the output would be false. So in this case, if I say this condition 1 is true, then it is dependent on the condition 2 also to get the final result for you. However, if I say the first condition is false, then do you really need to rely on second condition? No, right? Because I already got false here. Now anything I get in the world, right, will always give me false because it is AND operator. So in case of your AND operator, if the first condition is false, then result is false. Is not it? Very simple. This is AND condition. In AND condition, what is the rule? Both of them has to be true. Then only the condition would be true. If any of them is false, then it's gone, right? So if the first condition itself is false, then result is false. right? Then the result is false. Simple, right? So this is called as a short circuit operation operator. Now this is AND. Now similarly, let's talk about OR. Now if you put condition 1 and you say OR and you say condition 2, right? You said condition 1 or condition 2. So in case of this, see here, in case of this, if this condition is true, then this is OR, right? Now it does not matter whatever comes here. If it comes true or if it comes false, then you have decided the result. The result is true because the first condition is already met. Okay, so the second condition would not be evaluated, right? Now, if this is false, then it has to go and evaluate your other conditions, right? To derive what should be the result. If the first condition is false, then who knows if the second condition is true, then the output would be true. Is right. If the second condition is also false, then the output would be false. But if the condition is true in this case, then you are able to find out the final result. You are able to predict the final result, right? It's something very simple. You went to a bank to take a loan. Okay, and the bank, before giving you a loan, they will have multiple conditions. One condition could be if salary is greater than 10 LPA, okay, give them loan. And there would be further conditions. So if you met the first condition, why would somebody evaluate your further condition? It will say, okay, I got the first condition, you are true, and all these conditions are OR, right? OR. Right? Then why would I evaluate your other conditions? No, I got this. You are getting more than 10 LP, I will give you a loan. That's it, right? But if I change this condition to AND, right? And now you come to me saying that my salary is 5 LPA, you failed here itself. Why should I go and check the other conditions? Because you are not meeting the first criteria. I'll say, no, the first condition is not met, and then it's all done. Okay, so that's how it works. So now let's move on. We understood this, right? So let's go back and I'll share my screen and we'll go to all these concepts practically. So let me go back to share screen. So we are here, right? So it says and the double and OR, right, are lazy operators or short circuit operators, means they will not bother evaluating the second argument if the first argument is sufficient to drive the result. So let's try this out. So we'll do this practically. Okay, so let me copy this whole. I'll explain you this. Let me copy this whole and I'll say, okay, so I've defined these three variables x and y and num. Now my condition is this. Okay, now my condition is this. So see here, what the condition? The condition is simple. The condition is if number is less than x. What is the value of number, guys? 5. What is the value of x? 10. Okay, I'm saying 5 is less than 10. True or false? True. Yes, true or false? True. It's not it. So this is true. So if this is true, then now the condition is what? OR, right? So true OR. So true OR means what? So see, the first condition is already true, right? So do you think I should execute the second condition anytime? Yes, no, probably no, because true and anything in the world would be always true, right? So in that case, what happens? The second condition would not be evaluated. It will not be even touched because I know the result, like this is true. So I will not even care of executing the other stuff, right? So now the output would be true. It will print true. It will not print false. Okay. So let's say enter. So it printed me what? True. But then if I go back and try to check the value of y, print y, right? I went back and tried to print the value of y. What was the value of y, guys? Y value was 20, right? And if you see, since this was not evaluated, your y value is not incremented. It stayed at 20. Make sense? Okay. Now we'll try to do the same thing. But this time what we'll do is we'll put a condition and. Okay. We'll put the condition and. Remember the y value was 20 last time. Paste. Okay. Now see here. Num is less than x. What the value of num? Num is 5. X is what? X is basically 10. So 5 is less than x. True. That is true. But in this case, you have and, right? Which means it has to go and check the other condition as well to finalize the actual result. Okay. Now it comes here and y value was 20. Previously y value was 20 and y becomes y plus 1. So y value is 21 now, right? So y value was incremented to 21 and y is equal to 21. It is true because the value is incremented to 21. So y is equal to 21 is true and it should give you true. It should give you true. But what is the difference? In this case, what happened? Your second condition was also evaluated. And because of that, if you say print of y, right, it should give you 21. In this case, the second condition was also evaluated. In the first case, previous case, the second condition was not evaluated because the first condition was sufficient enough to drive the result. Okay. Now, again, you can do this like now the y value is 21. Okay. Now the y value is 21. So you can you can do something like this. Let me change it this way. Okay. So tell me here, what should be the output in this case? See here, num is greater than x. Num value is 5. Num value is 5. Okay. 5 is greater than 10. X value is 10. So what is this first condition? True or false? The first condition, true or false? So the first condition is false. So if the first condition is false, then will it go to the second condition here, guys? Yes or no? Will it go and evaluate the second condition? It should not, right? So because I got the result false and anything in the world, right? False and false, false and true, anything in the world would still give me false, right? So it will not go to the second condition, right? And it will just say, okay, I got this false, so I should go and print false, right? So the output should be false. But then if you go back to your y would be still having the same old value, that is 21, because that was incremented in the last run, right? So print y should still give you 21. Okay. So I hope this makes sense and if you understood what is the difference between this AND operator and single AND operator. Okay. So in OR, we have already discussed this. In OR, if the first condition is true, then second condition would not be evaluated, that means short circuited. Again, in AND operator, if first condition is false, then second condition will not be evaluated, that is short circuited. Okay, the logical AND or will have both the conditions evaluated. So now let me talk about this AND and OR as well. Okay, so we are going to talk about logical AND and OR. Okay, so we understood this double AND and double OR, but now I think we should put this discussion here. Okay, so let's understand what does it do. So this will also work on what? This will also work on your Boolean type. Okay, this will also work on your Boolean type. And how can you do that is something like this. You can say true and true, right? So true and true will give you what? True. Again, I'll say true and false. Sorry, true and false. Okay, so this gave you false because one of the condition was false. Again, true and again false and true. So this would also give you what? False, because one of them is false, the other one is true. Again, false and false. Okay, so false and false should also give you false. Like, yeah, I think I made a mistake that time. So false and false should also give you false, right? Because it's false at the end of the day. So this very similar to the truth table that we used to build in our school days, right? So in our college days. So let me copy this and I'll just put them here. So I'll work on it and then I'll make it a little beautiful later. Do the same thing, like you can just say, I'll go from here, true or true, right? So true or true, any one is true, right? So it is showing you true. And again, I'll say true or false, right? This will give you true. That also means false and true should give you false, or true should also give you true. And then you say true and true, that should also give you true, right? So in this case, if you see, if you have true anywhere, I think I should say false and false and false, right? So this would give you false, right? So in this case, true or true, right? So see, if you look into them, they look very similar, but the only difference is These are basically what? Are basically a logical operators. And in this case, the second, like there is nothing called short circuiting, right? If you replace this with this conditions, then your second condition would also be evaluated. Okay, so that's the biggest difference between logical and the unary end, right? So in logical, it is a short circuit operator, and then the short circuit operator concept does not work in your logical and all. Okay, so let me also paste this out, and then I'll work on it later. Yes, so they are basically same. Whatever you were doing in Java, they are exactly same. Okay, now let's move on. Now we'll talk about type inferencing, right? So we just discussed that type inferencing in a high level on day one, right? But then we will talk about this in more details. So type inferencing is basically the ability to determine the data type based on the value, and it is called as type inferencing. So always prefer using type inferencing instead of explicit type, since it makes the code short. However, you can use explicit type when you want to make sure that your intended data type is assigned. So that's what we call a type inferencing, right? So what does it mean? Like the ability for a Scala to automatically identify the data type based on the expression whatever you have written is called as type inferencing. Okay, and we always recommend that you always use the concept of type inferencing. Okay, earlier when I was learning Scala, I was also like, why is not put integer at the front to just tell that it is an integer, right? But then when I started working, I saw the folks writing a code without the types, and I understood that this is what the industry practice is, right? And that's how you should basically be using, and we'll be doing that a lot of times every time. Okay, now let me move on, and I'll talk about the bytes now. Okay, I'll talk about the bytes now. Look at this, it's very exciting. We'll say val x of byte is equal to 10. Okay, val x of byte is equal to 10. So let's try this out here. So say paste. So if I say val x of byte equal to 10 here, now the difference is if you just say is equal to 10, right, then it will be an integer. So now you may say, hey, when do you think I should be using type inferencing, and when should I specifically go and tell like express this byte, right? So now if you see val x is equal to 10, you have just written val x is equal to 10, right? Which means you are saying x would be of integer type, right? X would be of integer type, and then the x would be designed as integer. But then if you want to say, hey, I want to define 10, but then I want them to be treated as a byte type. So then you'll have to explicitly go and tell x should be a byte type and is equal to 10. So what happens is it creates a variable called x of byte type and would have a value called 10. Okay, now similarly, if you see val y is equal to 20.2 bytes. So 20 by default is integer, and if you want to assign it to a byte, then you should say dot 2 byte, and that is how it works. Okay, so let's do this as well. Okay, let's do this as well. So I'll say paste. Done. So val y is equal to 20.2 byte. So what it does, 20 is an integer, but you call 2 bytes, so y also became byte. Okay, so before that, I'll just go back and say this. Okay, so that my x is a byte and y is also a byte. So if I say x is a byte, and if I say y is a byte, and both these byte have value 10 and 20. Okay, every arithmetic operation that you perform will always return you an integer. In the below snippet, we are trying to add 2 bytes, which will return you an integer. Okay, so this is very important to understand that even though you are adding 2 bytes, this will always give you an integer. So please make sure that the byte and byte will not give you another byte. The byte and byte will give you an integer. The reason is because all the arithmetic operations results you in an integer. That's very important thing to understand. Okay, so well, z equal to x plus y, right? So x is a byte, y is a byte. We know it here from here, and byte plus byte should give you byte, but then add the plus in an arithmetic operation, and that gives you an integer. So 10 and 20 is 30, and 30 is assigned to integer value of is assigned to z of integer type. Okay. Now you may have a question. Hey, that's fine, but then I actually want z to be a byte type. What should I do? right? So you want actually Z of byte type. What should I do? So shall I do something like this? Maybe something like this, right? So shall I do something like this? Byte Z equal to value Z of byte is equal to X plus Y. But if you do that, then the problem is this is already an integer. And you cannot assign integer to byte directly like this. Okay, there is a flow. I'll talk about that. There's a flow and you have to follow the flow. So because see, integer is of higher type, right? So integer is a higher data type, and higher data type to lower data type will always need a typecasting. So you should basically do a typecasting here, right? But then let's go with the flow. Now what I'll do is I'll try to execute this. Look into this. What I'm doing is I'm saying X plus Y to byte. So what has happened is, what is this X? X is a byte, okay? Dot plus, right? So see, as we all know that, like plus is a method, right? Altogether. So earlier our logic was like this, plus Y, right? And this is what our logic was. But then, as we all know that this plus are really not I would say operators, right? They are basically a method in Scala. That's what we know. So can I not write it like this? Dot plus method pass Y. Okay, you can definitely do this. And when you do this, what it returns you? It will still return you an integer. So it is still returning you an integer. On this, you are saying, I got an integer, I know, but I want you to convert that into a byte. So you have converted your integer to byte. That is one way of doing this. Okay. Now look into this code. What does it do? So I'm saying X plus Y dot 2 byte, right? And when I hit enter, it will still give me 30 of integer type. The reason is very simple. See, X is already a byte. Y is already a byte. On this byte, you are calling 2 byte does not make any sense. Okay, useless. So this will still be a byte, but then you have an arithmetic operation done on it. And when you do an arithmetic operation, it will result you an integer. And on that result only, you should basically do a 2 byte. Otherwise, it is of no use, right? So if you do this, then byte plus another byte will still give you an integer, and hence you get 30. Z is of integer type. Let's try this out. We have tried this out. We said plus y plus x plus y. This is byte, and then I was trying to assign it to a byte variable, but then it says it's not matched because x plus y is going to return you an integer, whereas z is of byte type, and that does not work. Okay, no problem. While adding two numbers, even if the two numbers are of byte types and hold small values, still the result will be integer. So you cannot assign it to byte as shown above. That's what we have. Okay. Now, what is the solution? The solution is remove byte declaration from the statement and let Scala define it as an integer or explicitly declare z as integer. Right. So you can just say, okay, I don't want to have an explicit declaration and let it take it on its own, right? But then when you are doing this expression, make sure that you are actually typecasting it on your own. Okay. So when you try to do a typecasting, you can do a typecasting like this. So see here, x plus y. This is a byte plus byte. This is a byte plus byte. Now, byte plus byte would give you an integer. What is your requirement? You want to convert that into a byte, right? You want to convert that into a byte. So since you want to convert that into a byte, you can say, I got an integer here, dot 2 byte will give me a byte back, and z would be a byte type, right? So let's go back here. So within the braces, we evaluated the expression done, and the output is what converted to byte, and then hence you got a z of byte type. Okay. Now again, val z is equal to x plus y dot as instance of byte. This should also work. Here you are trying to do a typecasting. Okay, you are saying I got an integer, and this integer I want to see. This is an integer, and this integer I want to typecast to a byte type. Okay, this should also work, and it should give you z of byte equal to 30. Okay, now let's talk about the range of this byte. We already know the range. We talked about this range in our previous class, right? And we said that byte actually holds 1 byte of data, and 1 byte is nothing but 8 bits. Out of this 8 bits, 7 bits would be data bits, and 1 bit would be a size bit. So 7 bit would be data bit, that means 2 to the power 7, and 2 to the power 7 is 128, and then hence the formula goes minus 128 to 128 minus 1 is 127, right? So I hope we all know this formula, right? Now what does it mean? It means your byte can hold only numbers in this range. Okay, let's look into this. I'm saying value x of byte is equal to 127, and this is in range, right? So this should be all good, right? If you don't write this byte, then it will be treated as an integer by default, right? So that's the reason we said, okay, well, x of byte type is equal to 127, done. And then your 127 is assigned to x of byte type. Similarly, let me try this. I'm saying, well, x of byte is equal to 128. Let me say minus 128, okay? And if you see, well, x is equal to minus 128 was successful because it also comes within the range. But then let me try to say is equal to 128. Okay, so 128 is not in the range. If you see, it is not in the range. Okay, so it's saying, well, x is equal to 128, and it's saying 128 is of integer, and that would be out of the range. You will not be able to assign it because that is out of your range. Byte cannot store 128. But what can you do is you can say, hey, convert that into byte. So you are forcing that this 128, which is actually an integer, should be converted to a byte, right? And if you do that, then definitely this is not required on this side, right? Because it's going to give you a byte. So this is not required on this side. But then the result would be minus 128. Okay. So let me tell you how exactly it works. It works like a clock. Okay, this is very important to understand. It works like a clock. I have explained that in the Java lessons, but let me just explain you that here as well. So now let's talk about the cycle, right? So let's talk about how exactly the bytes are actually represented. In fact, all the data types, what we talk about, the integer type of data types, they are all represented with the help of a cycle. Okay, so we'll draw it like this. Okay, and now let's say we're talking about bytes, and one byte is nothing but 8 bits, and we all know that out of this 8 bit means all 8 boxes. 1 2 3 4 5 6 7 8 boxes. Now this would be a sign box, and 1 2 3 4 5 6 7. So these are 7 bits, and this 7 bits has the capability to store the value from 2 to the power 7 to 2 to the power 7 minus 1, right? Which makes it to 128 to 127. So this range, like this value can be represented in a cycle. Okay, so it starts with 0, 1, 2, 3, dot 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 dot, and it ends to 127. Okay, 127, 126, 125, 124, 123, and so on. Right, and again on this side 0, right? So 0, that means it is minus 1 here, then it is minus 2 here, then it is minus 3 here, minus 4 here. Likewise, it goes till minus 128, right? Minus 128. So minus 128, then you should have minus 127, you should have minus 126, you should have minus 125, you should have minus 124, minus 123, and so on. And that's how the cycle would look like. Okay, so that's how the cycle would look like. Okay, now if I say my byte v of byte type is equal to 127. If I say 127, right, then it is perfectly fine because 127 you can easily store, right? But then if you say 128, then by default it is like an error because 128 is out of range and it cannot really store. But then what you do is you will say 128.2 byte. That's what we were trying to understand, right? So when you say 128.2 byte, what does it do? This is 128, right? And then 128.2 byte, right? So what it happens is, see, 128 is nothing but 127 plus 1, right? So what will happen? 127 is this, and when you say 128.2 byte, it will go one step forward, right? And then the value would become what? Minus 128. the value would become minus 128. Similarly, if you say 130.2 byte, what should you get? If you say 130.2 byte, then it should basically go again in the forward direction, right? In this particular direction. So see here, this was 127, this was 128, 129, and 130. So this should be the value. So if you say, it should give you minus 126. Okay, so remember this, and then we'll talk about this. We have a formula to understand, and we will be able to understand it much more better. So let me go back. So let's go back here. So what we'll do is we'll try to create a byte first. Okay, I'll say, well, x is equal to x is equal to 128.2 byte, right? So this gave me minus 128. Again, if I say 129, it should say minus 127. Again, if I say 130, it should go one more step down. So 130 is minus 126, as what we have discussed. So that cycle would be rotating like that, right? So it's very simple. Like if somebody says, hey, I will meet you at 14 o'clock, right? Now there's nothing called 14 o'clock in a watch, right? It's 12 plus 2. So in that direction, that would basically go on. Okay. Now, well, x is equal to 127.2 byte. 127 is within the range, and it would be 127, right? Well, y of byte equal to 127. So they are different style of writing. So you can either write 127.2 byte, or you can say 127, and you can write y is of byte type here. That will work because they are all within the range, right? Okay, so let's do it this. Let's try to do this also. Okay, I'll say, give me a byte, 127. Done. I'll say, give me another byte. Okay, 127. Both are same. Both are the same value. They are two variables, x and y. Now what I'll do is I'll do x plus y. I'll do x plus y dot 2 byte. Now I got minus 2, right? How did we get this minus 2? We have to understand this now. So 127, how much it is? 254, right? So 254 is what we have got. Okay, so remember, we have got 254. We'll come back to this board again, but let me just write it down. We just got 254. Okay, so 254 what we got. So what will happen, that cycle will keep moving. Okay, every step it will go, and then it will go and stop at minus 2. Okay, now there is a formula to understand this, and we'll talk about that formula in some time now. So if I say x is equal to 128, then it is an integer. It is an integer, and if I then convert that integer to a byte, then it goes to minus 128 because of that clock, right? Okay, so let's talk about this formula, guys. Let's talk about this formula. So the formula is very simple. I learned this formula when I was learning C programming way back in 2007. Okay, so this is not a new thing in Scala. It is the same formula, works for C programming as well as for Java programming, except the ranges and all things put together. So let me go to this formula. I'll write this formula on the board. Okay, so let me just stop sharing. I'll go back. I'm just referring my notes so that I can give the formula. The formula says, it's very simple. If the number is n, and if this number is within the range, what is the range, guys? The range is this, minus 128 to 127, right? This is a range, is not it? So if the n is, I would say, less than or equal to, right, 127, and if the number is greater than, or equal to minus 128, if they are in this range, then number is the same, right? Because see, if I say 120, and if this 120 falls within this range, then what is the value of n? 120. Then it is the same number. Okay. Now, if n is greater than equal to 128, why 128 here? N is less than equal to 120. Because see, 127, if you say, then it is 127, obviously, right? But then if that number is greater than equal to 128 in this case, okay, then the formula becomes like this. The formula is n modulo 256, okay, minus 256. Let's see if that works for us. Now I have said 254. So we are under this condition, right? We are under this condition, and if we are under this condition, then the new number would be this number modulo 256, right? This number modulo 256. What is the value? 254 modulo 256. What is the value? 254 only, right? Because 256 cannot divide this 254. So the remainder is 254. Okay, minus 256. What will you get? Minus 2. Is that it? And that's how the result was minus 2. Similarly, if you take another value, you can take some other example. I will just use my board to explain you one more example. We have 500. Okay, 502 bytes. What will be the value of this? It's very important to understand. 502 bytes. What will the value of it? So again, what will happen is this 500 is go to the formula. This 500 is greater than 128. So what should I do? I should do a modulo by 256. Modulo, right? Modulo, not divide. Modulo. So when you do modulo by 256, I'll see what exactly is coming. 500 modulo 256 is coming 244. This is giving me 244. Right? Because see, 256, 1 is 256. What is the leftover? Is 244. Because 6 plus 4, 10, 5 plus 4, 9, plus 1, 10, 2, 2, 4, 5. Yeah. So if I do a 500 modulo 256, I get 244 as a reminder. On this reminder, I would do a minus 256. Right? On this reminder, I'll do a minus 256. And what the value out of it? The value is minus 12. Okay, and that's how we can validate that yes, this formula works. Now, on this formula, there is one more condition. If the number is less than or equal to minus 129, see here, you can go on this direction or you can also go on this direction, right? For example, if you say what is the value of minus 500, if you say, then it does not come under this. It comes under this particular problem, right? If the number is exceeding 128 is okay. Minus 128 means we know its value is always minus 128. But if the number is more than minus 128, that is at least 129 or more or lesser than that, right? So if 130, 151, 200 and so on minus, right? So if that is the case, then your formula would become n modulo 256 plus 256. Okay, very important concept, very important formula. So that's how the formula are designed, right? Okay, so we'll look into the board. We'll try to do that, and we'll see what is the output we get. So I'll go back and I'll share my screen. Now look into this. We were talking about this formula. We understood this. So if I say 500.2 bytes, if I say 500.2 bytes, right, it is giving me minus 12, right? Because of that formula. Again, if I say minus 1500 2 byte, then it is giving me 36. And why it is giving me 36? The explanation is here on the board. So minus 1500 modulo 256, what does it give? Let's do that. You are getting minus 220. So minus 220 plus 256, what are you getting? 36. That's how it basically works. Okay. Now, one thing I would like to tell you in this REPL, this is called as REPL, right? So this command line wherein you write all your Scala stuff, right? So this is called as REPL, REPL, right? Read, evaluate, print, loop. That means do the same thing again, interactive cell, right? So in this REPL, if you just say 1, if I just write 1, what happens, it creates a temporary variable called res15. Why 15? Because this is the 15th time I'm doing this. You start this and it starts from 0, res0. Okay. So now when I wrote 1, what it did is it assigned that 1 to a variable called res15. Now you can even print that by saying res15, right? See here, I just said res15, it is a statement. So what happened is this res15 was again assigned to another variable res16. So I should basically say print res16. Okay. 1. Now there will be no more assignment. But again, anytime you say 2 plus 4 plus 5, it is an expression. It will give you some output. That output would be stored in a temporary result variable res. Okay. And that's how you get the next number, res17. Right. And similarly, if I say hello 3, right? So I got hello 1, 2, 3. But then again, this is an expression. This would be evaluated and then it would be sent to it would be assigned to a new resultant variable. And that's how it works in your REPL. Okay, so that's why you will see all these numbers are increasing constantly, result 1, result 2, result 3, and so on. Now let's talk about one concept called the difference between byte and as instance of, right? So when should you use these two of them? So this is very important for us to understand when should you use two methods and when should you use as instance of method, right? So there are many 2xxx method which can be used to convert the data from one type to another type. For example, just go to your REPL and just say 10 dot, just write 2 and then hit tab. Okay, hit tab and it will tell you what are the two methods, two xxx methods available that can help you to convert that into something, right? For example, you want to convert it into integer, float, double, hexastring, long, short, and so on. Okay, or octal strings and so on. So there are two methods, and as we all know that you can also use as instance of to get your work done, but the point is what to be used. Okay, so there are many 2xx method which can be used to convert data from one type to another type. As instance of is a method which is present in any class. This is what we discussed in our yesterday's class, right? So you have a any class, the super class, and that any class has a method called as instance of, right? And it is used to typecast any object to any other compatible object. That is very, very important to understand. Your as instance of cannot do a conversion if they are not compatible. And if you provide any two incompatible type, it will throw you class cast exception. Now this class cast exception is from Java. Okay, it is not from Scala. This class cast exception has come from Java. Now, avoid as instance of and prefer 2xxx wherever possible, because as instance of throws error if there is a class mismatch. Okay, and 2xxx can be used only if only in those objects which contains such methods, right? Whose class contains such methods. For example, see here. Now, if I have an integer 10, 10 is an integer. Can I use two method? I can use two method because it supports, right? And it supports like you just say two and give tab and it gives you the list of all the two methods, right? But then if this does not support, then you can go ahead with your as instance of, provided they are compatible, that will work. So the whole agenda is very simple. Always try to prefer two xxx method. Okay, so always try to prefer 2xxx method so that you can do the conversion very easily. Okay, otherwise it is very, very difficult, right? So you just use 2xx method if the class supports, and if the class does not support 2xxx method, then you should basically rely on as instance of method. Okay, now let's try to look into this particular example. Let's see the below code. Like what I'm doing this time, if you see, I'm just saying create a number of 10 and assign it to any type. It is possible because any is always a root, right? Any is always a root. So you're saying 10, I want to create I want to create an integer value 10, but then I want to assign it to any, right? Done. Now when I do that, and let me try this out. And what I'm trying to do here is I'm saying if number, whatever I got, is instance of int, is that internally a child of integer actually? Then if yes, then convert it into integer. As instance I've used. Here I've used is instance to check if it is a child of int. And if it is true, then convert that into integer and multiply by 2. Okay, so what I did is I tried doing this, right? So what it should basically return you is it should basically return you a integer, Let me just say print. Okay, probably some more improvisation in Scala 3, but then it should have done that. Okay, but what I'm doing right now is but what I'm trying to do right now is I'm saying print so that the value can be printed, and it gave me 20. Okay, so just try it out on Scala 3, Scala 2. You may get little different output. Okay, but it should have written you something. If the condition is satisfied, then it should have written you something. But we'll look into that when we talk about the conditions, because we have this if conditions and all, that time we will be definitely catching this up. Okay, so I'll just change it to print. Okay, now see here, what we have done is 10 is an integer and I have assigned it to a parent. So what will happen internally the integer class is wrapped on any. Okay, integer class is wrapped on any, which means on this any, if you open this any, you still have the child class. And let me try to do the same thing again, but this time what I'll do is I'll say if num is instance of integer, yes, then I'm saying num dot to int into 2. So this should throw you an error. The reason is because this 2 int is not found. Why it is not found? Because num is of any type, and in num you should not see two such method. Okay, you should not see this two XXX method. You only have a toString method, right? You don't have any other two methods. And that is what it is saying. You like, I'm not able to find out the toString method properly, and hence I'll not be able to typecast it. So this example shows that if at all two methods are not available, then you can rely on as instance, but that as instance will work as long as they are compatible to each other. And if they are not, then if they are not compatible to each other, then it would be a problem.